All right. So someone yesterday on Twitter suggested that that title was actually written by my cat. So I just want to deny all those allegations. This is actually the intended title of my talk, Webtascalifragilisticexpialidocious. I'll be talking about Auth0 Webtask platform, which is our internal attempt within Auth0 at creating a serverless platform that was started prior to any of the other efforts like Lambda, Google Cloud Functions, or Azure Functions existed. So when we talk about serverless, I think there are many value propositions that resonate, and they've been kind of evident across the various talks earlier in the day. Serverless offers better abstractions. You think about individual functions rather than servers. Server is not a first-class concept in serverless. There is much reduced maintenance requirement on your part as a developer. Scalability is taken for granted, and people also frequently perceive granular billing as an added advantage. However, if you look at any set of value props around serverless, your perspective on it will be different depending on your particular scenario and the road you have taken towards serverless. So what I want to focus on in this presentation is the road we have taken within Auth0, how we are looking at this space, and I'll divide up that talk into two parts. First of all, how does the world look like on the side of someone who provides serverless infrastructure, simply because we have to build it ourselves? And also, how does the world we have created look like from the perspective of a developer who's using it? So Auth0, how many people are familiar with Auth0? Quite a few. So there was a workshop yesterday. I think many people who attended were exposed to Auth0. If you don't know what Auth0 is, you're missing out on a big part of your life. We offer identity management as a platform. So if you are building a mobile or web application, we are making it very easy to integrate authentication services into that application and move away from this aspect of application building as a concern for you, so you can focus on the business logic. Now, authentication and security space in general are very complex areas. They are configurable in 1,000 different ways. There are different radio buttons, switches you can turn, and so on. So a big part of our platform is the way we look at extensibility of that platform. At a certain point, that kind of declarative extensibility, radio buttons, text boxes, and so on, only get you as far. At some point, you have to drop down to actually writing custom code to customize the authentication experience beyond what the declarative experience can provide. So many SaaS platforms respond to this with the concept of a webhook. Webhook you can think is an ideal mechanism to plug in code-based extensibility into your platform or application. People come in, they configure a URL that your platform is going to call when a certain event occurs. GitHub is a good example. Someone pushes something to your GitHub repository. They can call a URL which goes to who knows what kind of system, written in who knows what kind of language that does something as a result of that event. So in a sense, it is an ideal decoupling from the perspective of what the platform does and what the extensibility point does, a protocol-based decoupling between these two systems. Slack is another example. Slack is very big on integrations using webhooks. So we started focusing on the webhook concept in general. And there are many things in the webhook concept that we did not like, which are kind of going against the entire idea of serverless. As a developer, once you are on point to plug in a webhook to a particular platform like GitHub, you have to find a place to host that code, you have to maintain that code, think about scalability, SSL certificate, maintenance, pretty much everything that is anti-serverless. So we started focusing on the question of, is there a better story to a webhook? Could we come up with something better? And the idea we came up with, we called Webtask. And a Webtask is effectively a serverless webhook. So if you think about this from the perspective of user experience, if your platform has a dashboard where people can configure things, like the GitHub dashboard when you put in a webhook URL, instead of that webhook URL, we want people to actually come in and write the dumb code right there. And we'll take care of running that code for you, scaling it. That entire layer of concerns that you typically face when implementing a webhook is completely gone. So this is a very improved user experience, I would say, but it put a lot of additional requirements on us as platform maintainers on Auth0. pretty much all the concerns that you had to go solve yourself as a developer of a webhook, we now have to do as platform maintainers. So Auth0 is a multi-tenant platform. One of the things that we have to think about is isolation between the code of different tenants. So if I have company foo implementing some piece of logic that they want on our platform and company bar implementing some other piece of logic, I want to ensure fair resource consumption between these pieces of code when they actually execute, and also data isolation. So a typical problem that historically places like Heroku, Windows Azure websites had to solve in the context of more granular web applications. So the way we approached that problem, we didn't really invent a whole lot. I think there are only so many solutions to this space given the components that exist today. We are using Docker as the basis for isolation, using all the cgroup mechanisms and namespaces that it exposes to the user. But on top of Docker, Docker itself is not enough to provide the kind of isolation we required. So on top of Docker, we also use PEM limits and additional networking constraints. So at the end of the day, we provide the level of desired resource isolation, CPU, network memory, files, as well as data isolation between apps, so that an app written by Mallory cannot access data that the app written by Alice created. Our primary execution model in web tasks is centered on HTTP. The reason for that is that Auth0 as an identity platform exposes authentication services over HTTP. So it was a very natural move from our perspective to mimic the same, to use the very same protocol to implement extensibility. Because effectively what happens, those small snippets of code that people write on our dashboard, they are executing within the lifetime of the authentication transaction, and specifically within a lifetime of an HTTP request made from the browser. So a specific leg of the authentication protocol, a request goes out to Auth0 servers. During the lifetime of that request, we are making out a request to execute some custom code. That request comes back. It may potentially augment the behavior of our authentication pipeline, and then we respond back to the user. So these are very short-lived interactions from that perspective, because we don't want the end user sitting there looking at a login dialog for 15 seconds, right? So in the simplest form of communicating with the Webtask runtime, which is the component that manages our serverless infrastructure, we are simply sending the code to be executed within the body of the HTTP post request over to the Webtask runtime. The runtime executes that code in an isolated environment and returns back the result. Now, the key concept of isolation that we have introduced, we call it Webtask container. In practice, it maps one-to-one to a Docker container today, but the concept of Docker container is not directly exposed in the programming model. So people tend to think of isolation in terms of Webtask containers. These are just some abstract names. They don't have to be pre-provisioned in the platform in any way. They are kind of created on the fly when the requests comes in. So this simple model of interacting with the Webtask runtime is what we are actually using in Auth0. Each of our customers will have a set of scripts defined on their account. When a request to authenticate a certain user comes in, we fetch that script, send it over to the Webtask runtime along with any request-specific parameters. Webtask runtime evaluates it and sends back the result. We also have the more traditional model where we support pre-provisioning of the code and any configuration data that code will require at runtime. So when you think about the code that you typically run on the backend, on one hand, it encapsulates some business logic in the form of the actual code. On the other hand, it requires access to certain secrets, because the primary reason to have some backend code running is to create a trust boundary between the client and the server. So the kind of secrets you want to enable that code to access are, for example, MongoDB connection string, Twilio keys, any kind of secrets that you don't want to leak to the client application. So that provisioning code to Webtask runtime that specifies the code to execute will also specify that configuration information. And then after that provisioning step is done, you can issue any number of requests to execute that code, which at that point is uniquely identified with an identifier. The advantage of that model is that it frees up the body of the HTTP request that is used to execute that code to contain application-specific data. It no longer contains the code itself, so you can send in, for example, the URL-encoded form post data, or you can send some JSON object to it if you want. And similarly to the previous model, the result, again, you have full flexibility of what you can send back. It can be JSON, it can be PNG, or it can be HTML. And the very last model is kind of a small augmentation of the previous one. You pre-provision your code and secrets, but also specify a schedule at which you want that code to execute. So we call this cron jobs. It allows you to basically schedule some background task that will happen at a certain interval. If you look at it from the perspective of the programming model, early on we have made a decision to focus exclusively on Node.js. And I'll come back to that decision later because that allowed us to make certain optimizations in how the platform operates. So the topmost example shows the most basic, the most fundamental programming model. As you can see, it resembles the HTTP handler in Node.js. So you are given the request and response object, and as such, you have full control over HTTP headers, content types, what data comes in and what data comes out. So we are trying to maintain a very close fidelity with the HTTP protocol that way. The context, the CTX, this is an object off of which we hang off a variety of utility functions, but this is also used to provide the secrets that you have provided to us as a Webtask runtime to the code at runtime. The latter two models are just simplifications of facades over that most flexible model. These are basically JSON in, JSON out. Latency had been an area of big focus for us. Given that the interaction that triggers execution of custom code is usually user-driven. Someone is logging in. There is a login dialog in the browser. They type in a username and password and click login. We can't afford to wait like 5 seconds or 15 seconds or whatnot for that transaction to complete because that would be a very poor user experience. So we spend a lot of time thinking how to optimize the latency, in particular cold startup latency, of creating those isolated environments in which code executes. And the design we ended up with is to use a pre-warmed pool of Docker containers. So when a request comes in to execute some code in a Webtask container that we haven't seen in days, all we really have to do is fetch a new, already pre-warmed Docker container from that pool, associated with that abstract notion of a Webtask container, and hand over that request for processing to that Docker container. So in effect, the cold startup latency in our system is negligibly larger than warm latency, which is the end result we wanted to achieve. And at that point, I want to come back to the notion of why did we choose Node.js as an exclusive framework for our needs. So first and foremost, we didn't see a business need to do anything other than Node.js. Our customer base is pretty much happy with just writing the pieces of code that they need in Node.js. But moving beyond that, focusing exclusively on Node.js allows us to create a uniform execution environment for all web tasks, and therefore enables that design of keeping a pre-warmed pool. Because pre-warmed pool only makes sense if you have uniform execution environment. So the interesting aspect that is, I think, different from other serverless offerings is that a uniform environment contains actually much more than you would find in Lambda or Google Cloud Functions and so on. We've looked at all the all the Node.js modules on NPM, which is like 400,000, around that number. We analyzed the download statistics for NPM, and it turns out that the Pareto rule applies there very strongly. So about 80% of all downloads from NPM boils down to 600 modules. So we took that 600 modules, and we jumped them into that execution environment. So if you want to use Mongo, if you want to use Express, any of the usual suspects, it's already there. So you don't have to zip it up into your dependency package. It's just there in that environment. And therefore, the code that you submit to execution to Webtask is usually very, very small, because this is just the application logic. Most of the dependencies are already there in the platform itself. So what I find kind of interesting about a conference like this is that we tend to have our heads in the cloud, like literally. You know, serverless is on the forefront of cloud computing, and cloud computing is on the forefront of IT. But the reality of the situation is that if you look at the overall IT landscape, you know, people out there are like 5 to 10 years behind what we are talking about here. So what we find from the kind of business perspective in Auth0 is that a lot of our revenue is coming from on-premise deployments. People just do maintain their own data centers for good or bad reasons, but they do. And you know, there is a huge pile of money to be had by a startup like ours if we go address that need. So therefore, we have focused on creating both Auth0 runtime as well as the Webtask runtime in a way that we can deploy in a variety of environments. So specifically talking about Webtask runtime, the things that enable us to move freely between places like AWS, Azure, Google, or any kind of on-premise deployment is to trim down the dependencies to the absolute minimum. And Webtask runtime really just has 3 dependencies, which is Linux, Docker, and Mongo. If you have these 3 things in your environment, we can go and run. And given that most of the Webtask technology deployments come bundled with Auth0 deployments, and Auth0 deployment already comes with MongoDB, it really boils down to Docker and Linux. And this is a pretty thin dependency set. So both Auth0 runtime as well as Webtask runtime, it is the same set of bits that we are actually running in the public cloud. If you go to auth0.com and sign up for an account, you'll be running in our public cloud, as well as on-premise. The slight difference there is basically in how that code gets deployed, the entire DevOps of maintaining that code, because some of the on-premise customers are literally disconnected from the internet. So we have to have a very custom process of how we go about maintenance of that code. So let's talk about scale a little bit. Scalability is mentioned often as one of the huge benefits behind serverless. And I think I'm going to say something controversial when I say it doesn't matter. At least it doesn't matter for 95% of the people, right? It is only the folks who are in the last 5% for which the possibility of scaling out the huge number of computing resources really will make an impactful difference on their business. So from the perspective of what we saw in Auth0 requirements of supporting the authentication as a service, the kind of higher scalability requirements fall into 2 buckets for us. One is a requirement where there are relatively few isolated Webtask containers, but they are running a high number of requests. So the customers that are falling in that bucket are typically big enterprises that want to isolate applications running on behalf of different departments. But these departments, by virtue of being really large, generate a lot of traffic. So this is the upper left quadrant. And we support that scenario in the Webtask technology by scaling out to a larger number of machines. The other scenario is the scenario of relatively low throughput, but a very large number of tenants. And this is the scenario of our public cloud. We have great many customers signing up to our public cloud. Great many of them only ever do hello world and forget about it, like any cloud platform, I'm sure. There is another great number of them who generate just a trickle of traffic, and there is just a small handful that has meaningful traffic. So these guys are well served by the bottom right quadrant. And our architecture supports that scenario by scaling up. So we basically throw larger boxes at the problem, and that accommodates more tenants. Now, the most interesting quadrant in this matrix is, of course, the upper right, high throughput, many tenants. We have a fairly good idea of how to go there. We just didn't do it because we didn't have a business need so far. So a lot of the effort in Auth0 in general and Webtasks as well revolves around developer experience. In a sense, we are obsessed about developer experience in Auth0. We really want to take a hard problem and boil it down to the bare bones to present a simple set of small number of concepts to the developers so that it is very approachable. And that problem had been very hard to solve in the context of security space, which is inherently complex. but we apply the same mindset when designing web tasks. So now I want to kind of switch gears and show you how using web tasks looks like from the developer perspective. So I don't know about you, but 20 minutes of slides is about as much as I can take, so I'll just drop down to console. So let's take the most simple web task, the hello world, which looks roughly like that. We basically write a function that takes context and callback and immediately calls the callback with a hello web task. There are two ways to operate, to communicate with the web task runtime. We have a web-based experience and we have CLI experience. So for CLI, you have to install a tool that we have, which is called WT. Once you have that tool, you call WT create hello. This is going to turn this piece of code into a web task and assign it a URL. Now you can call it, and it comes back with hello web task. So notice the latency here. This is the very first time our runtime out there in San Francisco knew about that isolated environment that it needs to create. So it was able to provision that environment, pull down that code that was created before, and execute it and return in that brief period of time. So let's do it again. Well, now it's warm, so it probably be slightly faster. But as I said, the difference between warm and cold is negligible in our platform, given how it is designed. So let's do something more complex. So let's talk about that scenario of provisioning secrets to your application. Let's say you have some key to some external system that you want your server code to have access to when it runs. So the way you create a web task to address that scenario is just you provide that key here. My key equals 12. So what this does, it bundles the code and the secrets, sends it over to the web task runtime. It is stored, encrypted, and protected on our servers, and it gives you back that URL. Now, the way you would access this in code is by accessing the context. So you can say, for example, your secret, and you can get it from ctx secrets my key. So I'm going to save this code, regenerate that web task with that key included. And now when I access this over curl, you'll see that my secret is available to the server-side code, and therefore it was able to respond with it. So this is a very simple way of passing secrets to your server-side logic so that you can access your Mongo database, send Twilio messages, and so on. So let's do something more advanced now. Let's explore that request-response programming model, which gives you full flexibility of controlling the content of the HTTP request and response. So in this case, the way you would, this is a regular Node.js code, so you do something like res and, or you can, for example, respond with hy, hello world. So let me regenerate that web task. Now actually I'm going to open it up in the browser. Did I regenerate it? Did I save it? Let's do it again. And hello world comes back. So you can, this demonstrates how you can send back HTML, not just JSON, or you're not constrained in what you're doing with HTTP. So now let's take it to a next level. So if you can do, if you can have full control over request and response, why the hell cannot you do Express, for example? Yes, you can. So the Express would look like this. And this is a good time to actually break into the web UI experience. So you can do WT edit and web task that I have created before. So this pops into our web task editor, which is a hosted experience offered by the web task runtime itself. So what you have in here, you've got the actual code of your application and the access to secrets. You can also specify secrets through the web UI, similarly to what you have done with the CLI. But let's have a look at that code. So we are pulling in Express, first thing. we are creating the routes just as we would create routes in the regular Express application. And then the only difference is that the function that we return from that module is transformed using our built-in helper function from Express. So we are taking that Express application and you are effectively creating a single function that matches that prescriptive pattern of the Webtask runtime requires. So this is going to return hello serverless conf. I'm going to run it from here. And you'll see the result comes back. You can inspect the result, and you'll see that this is exactly the HTML we have generated down here. So this also brings in the other part of the online experience, which is real-time access to logging information. I think it was mentioned in one of the talks before is that the development experience is going to move more towards cloud. And this is how we kind of fit into this picture. If development moves to the cloud, you really have a good way, you must have a good way to debug the code that is running in the cloud. And the first step towards a good debugging experience is access to logging information. In the simplest form, it really boils down to surfacing what you do with console log. So I'm doing something simple like console log here, running it again. Let me just clear the console. And you'll see that that output shows up here. So at the very minimum, you get a very robust console log debugging experience. And by the way, the same logging experience you can get through command line tool. So you can connect to our streaming log endpoint. When I run my Webtask again, that output shows here as well as in the command line. So this is quite an interesting setup. We don't have the time to go into this, but the big part of that solution here is ZeroMQ, which allows us to consolidate logging information from across the cluster of servers that support the Webtask runtime and surface it over a single HTTP endpoint to the client. So lastly, Auth0 is, we offer authentication, so it will only be fair if we offer the decent security experience for our Webtask. So how do we protect it? Let's say now we can surface HTML, so it's only reasonable that there is some kind of a logging experience to your HTML. So how do we do it? Let me break into another one, which is edit secure. So you'll notice that this is a very similar Express app as before. The only difference in code is the addition of Auth0. So Auth0 is like a verb. It is used to secure your application. And in addition to providing that verb, you really have to also specify the Auth0 credentials. So you would first go to the Auth0 dashboard, sign up for a free account. You would get those credentials, and this is how you specify them. This is kind of on par with what you would do going to Twilio, getting their keys and plugging in there. So this will make this piece of code protected with a specific Auth0 application you have configured elsewhere. So let's save it. And I'm going to navigate to this secure endpoint now, the Webtask. And this is the logging experience that you get out by default, which is pretty much the Auth0 login dialog. And when you log in, you go back to your Webtask. This time you are completely authenticated. And your server-side code at this point has access to the user profile. There is also additional mechanisms that allow you to add simple authorization rules and so on. So we made it also simple to integrate authentication into your Webtask experience. So just to show something cool at the end, given the flexibility of exposing HTML from Webtask, you can build a very simple web apps, I would say. And one of them is ready-made here. So this is a Webtask that responded to an HTTP GET, but by serving a piece of HTML that you are seeing here. That piece of HTML is a simple form, HTML form. So you can say, for example, an alias of someone on Twitter here, Janczuk, which is me. And when you submit that form, it will generate an HTTP post going back to the very same Webtask. So if you picture your Express application at that point, it would have two endpoints, a GET and a POST, right? It is the same piece of code. So when I do this, the post will go out to the server. The server will actually go talk to Twitter using my Twitter APIs that are baked into this web task, and will generate a word cloud of what I'm tweeting about. And you can see that I'm mostly tweeting about Node.js. So let's go and check out what serverless conf is tweeting about. And as expected, it is serverless. So this really concludes my presentation. Thank you. Webtask.io is where you can go and check out, play out with the concept of the web task. And there is one last thing I want to say, which is Auth0 does really two things. I forgot to mention that at the beginning. We do authentication, we do web task, and we also hire like there is no tomorrow. So, and we hire remotely. So, you know, if any of this resonates with you and you like to eat nails for breakfast, please talk to me. Thank you.